Now we look at one more way that average rates of change can help us understand and interpret functions, and that is looking at the concepts of increasing and decreasing functions. So what we're going to do is we're going to connect the average rate of change to the concepts of increasing and decreasing functions. So let's think about the graph of some random function y equals f of x. And this isn't a particular function, this is just a random graph of a function that you might get. So a couple things you might notice about the graph is, first of all, some parts of the graph go uphill, like what we're pointing to there. So if you go left to right, the graph goes uphill. And there are other parts of the graph where if you go from left to right, the graph goes downhill, like in those two parts. And so whether or not a graph goes uphill depends on whether we call a function increasing or decreasing. And it could be that a function is not just intrinsically increasing and decreasing. It could be increasing in parts and decreasing in other parts. So let's see what we mean by those two terms. So let f be a function. We say that f is increasing between x equals a and x equals b if the graph always goes uphill between x equals a and x equals b. And we say that f is decreasing between x equals a and x equals b if the graph is always going downhill between x equals a and x equals b. And one of the things I want you to notice about when we say a function is increasing and decreasing, it's increasing or decreasing on an interval between 2 points, between one value of x and another value of x. So we always have to specify those when we're talking about a function increasing or decreasing. All right, so we can tell when a function is increasing or decreasing by looking at the graph, but what if someone gives us a function, we don't have the graph at hand, and we want to tell whether it's increasing or decreasing just by doing computations? Well, it turns out we can do that. So let me get the graph again, and let me look at 2 points along the uphill version of the graph. In other words, 2 points where the graph is increasing, and see what we can tell about the average rate of change between those 2 points. So the two values of x are x equals a on the left and x equals b on the right. And if we look at their outputs, f of x equals a is right, or f of a is right across from the point where x equals a, and f of b is right across from the point where x equals b. And let's look at what the average rate of change is for these two points. So the first thing to notice is that f of a is smaller than f of b. F of a is lower on the y-axis than f of b is. So if I want to look at f of b minus f of a, I may not know exactly what the number is, but since I'm taking a bigger number f of b and subtracting a smaller number f of a, that's going to give me a positive number. What kind of a positive number? I don't know, but I know it is positive. And similarly, I know that a is less than b because it is to the left of b. And that means if I take b minus a, I'm taking a bigger number b and subtracting a smaller number a. And again, that's going to give me a positive number. So when I look at a graph going uphill and I look at f of b minus f of a over b minus a, I know in the numerator I'm going to have a positive number, and in the denominator I'm going to have a positive number as well. So while I may not exactly know what that number is going to be, I do know that it's going to be a positive number. So when a graph is increasing, when the graph is going uphill, when a function is increasing, that means the average rate of change is going to be a positive number. Now let's see what happened when we look at a portion of the graph where it's going downhill. In other words, where the function is decreasing. We're going to do the same kind of analysis as we did before. So now again, f of a is right across the point where x equals a. F of b is right across from the point where x equals b. And notice that the relative positions of f of a and f of b have now switched. So now f of a is above f of b, which means f of a is greater than f of b. So when we take f of b minus f of a, now we're taking a smaller number f of b, subtracting a bigger number f of a, and that will give us a negative number. However, a is still less than b. A is still to the left of b, just like it was before, which means that when we take b minus a, that is always going to be a positive number. So now when the graph goes downhill, in other words, when our function is decreasing, when we look at f of b minus f of a over b minus a, that numerator is now going to be negative. The denominator is still going to be positive. I get a negative number divided by a positive number. That's going to give me a negative number. So when our function is decreasing, that means the average rate of change is negative, which gives us a more precise way of defining what it means to increase and decrease. So now our formal definition of what it means to be an increasing or decreasing function on an interval. We say that f is increasing between x equals a and x equals b if the average rate of change is positive for all values between x equals a and x equals b. Not just that the average rate of change is positive between x equals a and x equals b, but if I were to happen to choose two random numbers between x equals a and x equals b, the average rate of change will be positive there as well. And we say that f is decreasing between x equals a and x equals b if the average rate of change is negative for all values between x equals a and x equals b. And again, that means if I choose any two values of x between x equals a and x equals b, not simply at x equals a and x equals b, I will always get a negative number. So what it tells us is that increasing and decreasing intervals of a function tells us where the graph is going uphill or downhill. It tells us where whether the outputs are getting bigger or getting smaller. The outputs are increasing, the outputs are decreasing. And it also tells us whether the average rate of change is positive or negative. All right, so now let's see if you can practice some of these concepts on the class activities that are attached to this video. It's called average rate of change and in parentheses interpretation.